In other words, while in all likelihood no asteroid impact will occur, with a 98.1% chance of it passing harmlessly by the planet, there is a 1.9% chance that an impact could occur along an area ranging all the way from possible impact locations a portion of the remote Pacific Ocean 1,500 miles east of Hawaii's Big Island to Colombia, Nigeria, Ethiopia, India, all the way to southeastern China. 2024 YR4 has a range of potential sizes ranging from 40 to 90 meters wide, but our best current guess suggests that this asteroid measures asteroid information 54 meters or 177.2 feet wide and has a mass of approximately 220,000 metric tons. While the most likely outcome by far is still that no impact will occur, the odds of an impact occurring on that future date in 2032 have gone up from 1.2% during initial observations to 1.4%, to 1.7%, and then most recently to 1.9%. However, as more observations are made, the possible long-term trajectory of 2024 YR4 will be narrowed, and in all likelihood these future observations will most likely completely rule out an impact at some point in the future. The next series of observations will be made until April 2025 and then during 2028. I want everyone to recall that something similar happened after the discovery of the Apophis asteroid in 2004, which was initially given a 2.7% chance of impacting Earth in 2029. However, as additional observations were made, the potential path of Apophis was narrowed, leading to the eventual realization that the odds of it impacting Earth were actually less than 1 in a million. So, what else do we know about this asteroid? What might be expected if it did collide, and how damaging would it be? First, 2024 YR4 is believed to be either a Type L or Type S asteroid, both of which have a low density that indicate a likely chondrite composition. Asteroid impacts typically occur at very high speeds which can vary anywhere from asteroid factors 11 to 22 km per second. Other factors which make asteroids more likely to impact the surface include a larger size, higher density, not having a highly oblong shape, and steeper impact angle. Density is the most important of these factors as a falling bowling ball is much more likely to harm you than a falling basketball despite being essentially the same width. Airbursts: if an asteroid is on the smaller, less dense end, but still larger than only a few meters across, then it is unlikely to reach the surface but will explode within the atmosphere through a process known as an airburst. These airbursts can still theoretically kill millions even from a modest-sized asteroid impact in a worst-case scenario, so their threat needs to be taken seriously. One example in the 1908 Tunguska event where a 65-meter asteroid entering Earth's atmosphere at a shallow angle exploded at an altitude of 4.5 kilometers or 14,800 feet, resulting in the burning of 200 square kilometers of landscape, several deaths, and the flattening of 2,000 square kilometers of forest. While 2024 YR4 is smaller than the modeled Tunguska event impactor, it is more dense and expected to enter the atmosphere at a steeper angle. So, possible damage: while the formation of a meteor crater-sized crater in the ground is somewhat plausible, the most likely outcome if an impact was to occur is for 2024 YR4 to explode in an airburst at an altitude of 7.5 kilometers or 24,600 feet. If that occurred over land, this would be sufficient to collapse structures in an up to 8-kilometer radius on the ground through an up to 314 mph shockwave, and cause a high rate of fatalities and burns up to 20 kilometers away. In other words, this cold be regionally destructive to possibly a few cities, but nothing civilization changing. If it is eventually determined that an impact is certain from 2024 YR4, I suggest launching a spacecraft mission, possibly more than one, to divert the path of this asteroid. I am not too concerned about this asteroid quite yet, as a 1.9% chance is still very, very low. As a final note, I would like to thank my new patron Jim for supporting this channel.